environment. Great. So let's get started here. We're at Sysdig, we're all about container native monitoring, and this is the Kubernetes edition. And so when people like to tell a story of two products integrating, it's frequently kind of like imagined as a burger and fries analogy, which is a pretty good analogy. It's kind of a tasty meal to look at, but I think with our integration, we're trying to push it a bit further. And instead of putting the fries next to the burger, we just put the fries right on the burger. That's how deeply integrated we are with Kubernetes. And I'm going to show you what we mean by that and the power of what we can do. I'm sure that by the end of this, we'll be, we'll only be a short ways away from lunchtime, and this might make you a little bit hungrier, but it'll warm you up for lunch. So monitoring containers, it's what we're about, and it's fundamentally different because microservices and the containers that they're built off of break legacy monitoring and analytics tools. Sysdig, however, is the first and only solution that's container native, which means we can monitor containers, the microservice built on top of them, as well as legacy infrastructure like virtual machines and bare metal as well. Okay, so you're probably asking, well, why are monitoring containers different? Well, legacy monitoring approaches simply can't see inside containers. That's the number one issue here. Containers were designed to be black boxes that were reportable among different clouds and different environments. Flip side is, however, you can't see inside them. The trouble with that is that running monitoring agents inside containers isn't a viable solution. If you're thinking about the Docker philosophy, it's designed to isolate a single process per container, thereby giving you the portability and flexibility that you're looking for. If you start layering in monitoring agents, you break that. Finally, monitoring tools built previously weren't really designed to understand microservices architecture as well as container orchestration. So as your customers or your internal customers or your team goes to use these tools, the older tools are not going to mesh the workflow of what's necessary for today's environment. So Sysdig has taken a very different approach to this by leveraging an entirely new type of instrumentation. We call it container vision. And Sysdig Cloud's agent can be deployed as a container or a process. But through our unique instrumentation, you do not need to deploy us inside any other container. We deploy as our own container. And from that vantage point, we can see inside your other containers, as well as down into the underlying host infrastructure and orchestration tools that you need to understand your environment at large. So I would like to explain to you how this works and give you a little more technical detail, and you can see that this is going to be pretty differentiated from what other monitoring solutions do. So take this, this environment here. We've got some different containers running, some apps running that are non-containerized. They're all speaking with the kernel for the host OS in order to do whatever they need to do. What Sysdig does is we actually turn on a kernel module in the host OS. And from this vantage point, we can see every single system call that every single container or application or process makes. Using and capturing this information, we can then send it to our Sysdig container for collection and analysis. And by doing this, we can fundamentally see inside every other container and what it's doing without having to instrument each one individually. All right, I'm going to stop here and just see if there are any questions. This is usually a place where people do have questions about how this works. But this type of instrumentation is absolutely fundamental to what we do, and it's very differentiated. I don't think there's anybody else out there who provides this level of instrumentation. All right, so please feel free to chat in any questions as you have them. In the meantime, let's talk about what this instrumentation gets you. And fundamentally, what it gets you is better visibility into your environment. Typical infrastructure monitoring products will tell you just fine if your host is up or down, your memory utilization, your CPU utilization, but it tells you very little about the operations of your entire environment. How is your application performing? What who's communicating to whom, what's the user experiencing. And based on this new instrumentation model, Sysdig can actually tell you a lot more. And we break it down into 3 categories here: service-oriented performance management, application intelligent monitoring, and trace-driven troubleshooting. So I'm going to walk through each of these in just a little bit of detail. First of all, service-oriented performance management. As you start to leverage orchestration tooling and containerized infrastructure, your containers could be spread out across many different hosts or different data centers, different clouds, in order to achieve the service resiliency that you're looking for. But the way those container orchestration tools work is they're not going to nicely organize each set of containers according to what service they're supporting. They just spread them out for optimal resource utilization. That's great for efficiently utilizing resources. It's not so great for understanding how things are performing. So what Sysdig allows you to do is take all of that data and re-aggregate it into a service-oriented view. So an example, what's the response time of my Cassandra service that's currently distributed over 3 data centers? More importantly, what are the slowest queries right now? What are people experiencing that is just not working? This is a question, or these are questions that your traditional infrastructure monitoring tools wouldn't give you, but we can. And the way we do that is by a deep real-time understanding of orchestration metadata. So with these products you see here, Mesos, Docker, Kubernetes, and your clouds such as Azure, Amazon Web Services, and Google, we collect metadata from this environment, and we allow you to then apply that metadata to all of those metrics you're collecting, those thousands of metrics you're collecting per container, and give you an aggregated service-oriented view. And again, I'm going to show you this in the demonstration. This is absolutely critical to what we do and very different from the approach that monitoring tools have taken up to date. So this webinar in particular is about Kubernetes. So let's talk about the Kubernetes integration in particular. You can think of this as like kind of like a hierarchy of self-enlightenment. You start at number 1 here, and you ask, well, how are my servers running Kubernetes master and minions doing? Are they up? Are they down? Next, you can say, well, what if I tap the Kubernetes API and graph those whatever metrics I can collect from it? That's helpful. It gives you a little bit better sense of what's going on. But finally, what if you could monitor your services that are deployed with Kubernetes? Grab data from the metadata from the API and then map those against all the relevant containers. And that's exactly what Sysdig Cloud does. So what we do is we're monitoring each container and application using container vision instrumentation, as we described before. At the same time, when you deploy our agent on a Kubernetes master, we're polling the API. We auto-discover it and poll the API to collect all of the metadata that is available about your system. Examples of metadata would include replication controller names, namespaces, pods, and container IDs. Once we've done that, we can then dynamically aggregate metrics across all of these core metadata categorizations like namespace, replication controller, and actually then allow you to ask the question, well, how's this namespace doing? How is this replication controller doing? If it's a, for example, database replication controller, what are the slowest queries we're facing, and so on. Should probably stop there and see if you have any questions. All right, no questions yet. Quiet audience today, no worries. Okay, so next, let's talk about application intelligent monitoring and alerting. What we want to do here is make it really simple and easy for you to get application level information about what's running in your container. So not just how's my container doing, but how's my app inside the container doing. And we do this in a very simple and easy to use way. We actually give you automatic discovery. No plugins. We figure out what applications are running and automatically start monitoring those. On the flip side, once you're in the app, we also have templates that give you pre-built views into those applications and services. Because so many people also use custom metrics for monitoring their applications, we've enabled a zero config model for collecting custom metrics as well, StatsD and JMX. And finally, anomaly detection for outlier and deviation-based comparisons make it pretty simple to understand what's going on in your environment. Again, another example, developers spun up a new service based on Apache and Mongo last night without letting us know. We had deployed Sysdig, so we also see it all without any additional config. And as I mentioned, we automatically discover a ton of applications with no plugins, nothing necessary on your end. This is a sample of the logos of application integrations we have. If there are applications that you're looking for that we don't have, two things we can do. One, you can just let us know and we can write that for you. Two, you can always write a custom application check. This is especially valuable if you're monitoring your own custom code. And once you write that application check, Sysdig will be able to auto-discover any new instantiations of that code for you. So auto-discovery applies against custom applications as well. Okay, so the last item here is trace-driven troubleshooting. And most monitoring tools give you a dashboarding environment. That's nice. It kind of lets you see metrics. But we wanted to take that much further, and we do this through our integration with our open source technology, which goes by the same name, Sysdig. With that, you can, of course, create dashboards, but you can also correlate events with those dashboards. Those events could be alerts, but they could be events from different systems, like Kubernetes logs or code pushes from Jenkins, so on and so forth. Finally, on an alert, you can actually trigger a capture of a trace file. And a trace file is a record of every single system call being created on that host at the given time of the alert trigger. So that allows you to go incredibly deep in terms of troubleshooting what's going on in a host or a set of containers. And in fact, because we capture this as a file and store it remotely, it gives you the ability to troubleshoot containers even after they're long gone. Okay, so it's time for a lot. That's a lot of talking, but we want to hop into a demo environment here and show you actually what we're doing. So we're going to show you a small environment with and without orchestration. We're going to show you how to deploy Sysdig, and so this is something that I think no other monitoring tool would ever do in their demo, which is actually show you how to instrument the system and get all these metrics set up and going. We want to show you the three things we just talked about: service-oriented performance management. We're going to show you a deep troubleshooting example, which shows you application intelligent monitoring, as well as trace-driven troubleshooting. All right, so give me a moment here to share my web browser. All right. Okay. All right, so what you see here is a demo environment that we already have running, and we've got a topology map here. This topology map is dynamically created from Sysdig once you've instrumented your systems, so there's no work involved. It's always up to date in real time. And what we're showing you here is a physical map. So what you can probably see here are these IP addresses, which represent the actual hosts we're using in EC2 and how they're communicating with each other. Now, as we talked about in a containerized environment, like this demo that we're running here, these communications between hosts aren't particularly useful. What's more interesting is to understand the services you're running and how they're communicating. So if I hop over here and click on this another dashboard, which creates a semantic or logical map, now what you see is an environment broken up first by Kubernetes namespaces. And so let's focus in on the production environment. And now as I zoom in to the production environment, I'm actually looking at replication controllers. And so these essentially are the services running within our prod namespace. And if I keep diving in here, I'll actually see the containers that make up this particular a replication controller or service, and how they're communicating with each other. This map is totally configurable. So right now we're looking at CPU as the main characteristic of each of these boxes, and each of the lines is made up of these are requests per second right now, and so these are entirely configurable. All of this is dynamically created, and I'm going to show you how we get all of this data. And the way we can do that is actually, I'm going to start by hopping over to an empty environment and actually show you how we got this data. So here you see another Sysdig environment. This is my private environment. There's no data coming in here right now. So let's get data in here. I'm going to hop over to a terminal window. Let me just share my whole desktop here. And let's hop over to a terminal window and hop into AWS. This is my AWS environment. And let's clear this up here. See what we've got running. So we've got a couple containers that are running right now. And I'm going to just get my command set up to install Sysdig. And I do that by heading over here to the gear. This is the admin section. And I go to agent installation. And you see we have instructions here for various forms of agent installation: Docker container, CoreOS, or bare Linux install. And so I'm going to use this command for the Docker container because I'm running in a containerized environment. Let's hop over to my terminal. And now what's happening is Docker is grabbing the most recent version of our agent, applying our access key to it, installing our kernel module. And once it installs the kernel module, it will start seeing every system call that's being made by those containers that I have running in this environment. And so now it's starting to send that data back to Sysdig Cloud in this case. So once we hop back here into our environment and hop into here to see what we can find, and it usually takes somewhere between 30 seconds to start seeing data flowing back into this environment. And here you see it. There's my host, and we're seeing information about CPU, memory, network, and so on for this host. But what's more interesting, of course, is if I drill down, I actually see the agents running on this machine. And so, or pardon me, the containers running on this machine. And so without having to have done any instrumentation to those containers, we can start seeing those containers. But we can go even further. This is conveniently labeled MySQL, and this is a MySQL container. But let's click on this and see what happens. This gives us those predefined views that I described. And in this case, it's a container overview, and it's pretty much infrastructure information. But if I type in MySQL here, you can see I get various MySQL application views. And as I click on one of these, you're going to notice that this is a very different view. So now you're not really seeing CPU memory disk, but you're seeing number of requests, errors, average request time, top queries, top tables, and so on. So we're getting application level information from the MySQL container, but we didn't have to do any additional instrumentation. We didn't have to tell Sysdig we were running MySQL. We're able to discover this all on our own. And that's incredibly powerful from two levels. One, really, in reality, you don't care how your container is doing. You care how your application is doing. And this is the level of information that tells you how your app is doing. Secondarily, containerized environments tend to be incredibly dynamic. And this is a Kubernetes-based environment. You can imagine Kubernetes spinning up and spinning down MySQL containers as necessary. We'll always be monitoring this information without you having to tell us what to monitor. All right, so what you just saw is how container vision enables you to instrument a system and see deep inside the containers with what we call passive instrumentation. Let's hop back to our more complex environment here, which is the Kubernetes orchestrated environment, and show you a few more things here. Okay, so first of all, just like we were talking about the services before, we can get a service performance dashboard here for your web application. So for the web application front end, again, you can see not just CPU utilization and the like, but you can see things like HTTP error rate, response time. You can obviously graph those over time. You can see top URLs by number of requests. You can see slowest URLs. So this is a really powerful way for you to monitor your web app service and understand how well it's functioning. In addition, we could do something similar for your service, your database service. And again, this looks more similar to the MySQL information you were looking for. In this case, it's actually Mongo based. All right, so kind of first things first, kind of understand your environment. Map out that topology, understand how it's performing, understand how your services are performing. But as I mentioned, this is a Kubernetes-based environment, so we could similarly click on this Kubernetes-based view here. This is an overview, and now you're looking at very Kubernetes-oriented information. Request counts by service, top namespaces, by containers, containers per host. Host capacity utilization, slowest resources, top resources, so on. So again, this is a pre-built, this is a dashboard we built, and I'll show you how to build those in a moment, but this is all due to our Kubernetes integration. So the one question that probably is floating around in your mind is, well, how did you get from a place of just instrumenting hosts to actually seeing what those services were? And I think the best way to show you that is through our Explore view. And oops, I forgot to reset this. Pay no attention for 1 second here. Let me start from this view, which is very similar to what you'd expect to see from a monitoring tool, which is let me see my hosts, and in this case, since this is all dynamic, you can see the containers running on that host. As we talked about before, you could click on any of these to get more detailed information, but instead, let's apply a different grouping. And grouping leverages metadata we collect from orchestration systems or clouds to give you a new view. And so as you can see here, we have a default Kubernetes view. And if you read this, it's basically creating a hierarchy on Kubernetes namespace, replication controller, pods, and then containers. So when I apply this, now instead of IP addresses, we're getting namespaces. And if I'd like to get more detail on this namespace, I could click here, and any view that I'm receiving is now showing me an aggregate of that namespace. So here I'm looking at the prod namespace, and I'm getting a container overview in prod. We have a number of pre-built Kubernetes dashboards as well, and so let's drop in here. Since we're looking at the prod namespace, let's see all the replication controllers in the prod namespace. And now you'll see a view similar to that dashboard we just created, where we're looking at all the replication controllers and namespace prod, and you can see top RCs, RCs by container count, by memory utilization, so on and so forth. Again, all out of the box, no configuration necessary. Now, we may be more interested again in the services that are running in prod. So as I drill down here, what we're actually seeing is the actual services that we care about here. And I could drill into, for example, Mongo. Okay, so in Mongo, we kind of see very similar data to what we were looking at before. Let's do a couple things here. Let's start to create a dashboard. One, you can simply come in here and pin any chart you're looking for to a dashboard. So if I type in new dashboard here, then I can pin it. I can pin it and directly open that dashboard. I'm going to skip that, and instead, let's create an alert. We can create an alert by clicking on Add Alert. Sysdig uses an adaptive alerting policy, which means that as you create alerts, you set a scope with tags and metadata. And then as containers come and go, any container that has the same metadata automatically inherits the alert. You can set a condition, which is either manual or anomaly detection using baseline or host comparison mechanisms. And you can set a threshold. For example, you could set a threshold where bytes is greater than 50 or whatever. You can switch to an advanced mode, which lets you do multi-condition alerting. So you can do things like CPU use percent and time, or pardon me, memory average over a particular amount of time is greater than X. So you have really flexible ways of creating, creating that information. Okay, and then finally, you can, well, not finally, but you can specify information included in the alert, and you can say where you'd like the alerts to go to. Email, Amazon SNS, Slack, PagerDuty, and the last one, which is creating a Sysdig capture. And as you'll remember when we talked about trace-driven troubleshooting, when you have an alert that fires, you can create a capture file which shows you every single request for every single container on a particular host when an alert fires. And you do it right here. This is where you create it, you set a time frame, and you can actually filter out specific calls. All right, so let's just very quickly walk through a troubleshooting workflow. In order to do that, I'm going to log out of here for a moment. You're going to actually see my Slack environment, and we can see that we've got some alerts here. This is what a Sysdig Cloud alert looks like. I'm going to view this. You can see here I can view this notification. It's probably going to force me to log in. We're logging into this environment, and it's going to take me immediately to that particular notification. And we can see here, this is our alert environment where we have all our notifications, but we're looking at this particular one, and we can see this spike above our threshold here. So what we can do is now explore the notification. Exploring the notification takes us back into our Explore environment with the time set for an hour around that alert. And you can see some pretty interesting facts here. So first of all, we can see Mongo, we can see network spiking. On our time chart here, we actually see events or alerts overlaid with our metrics. And as I mentioned, these could be Sysdig alerts, but these could be events from other systems that you're importing via our API. And now you can get great context and visually correlate whether those events are related to those metrics. And you can see here we're taking average and we've plotted as a time series and we're segmenting by server port. So this isn't really very interesting because all the data is on one server port. So instead, let's segment by container. Let's do it by container name. And what we see is, well, this isn't helpful. Mongo's traffic drops when that alert was fired. Okay. So let's instead look at all the processes running on this machine. And if we look at this number, interesting. Okay, so it's this process main that is spiking on this host. It's not the Mongo container. So we've been able to understand that, okay, whatever is happening on this Mongo container and traffic is spiking isn't actually coming from the Mongo container itself, but from the process running on the machine. Now, if we wanted to, we could also open a trace file, which would show us much deeper information. It would be, pardon me, I lost my train of thought. The trace file was a triggered event that happened when this alert was fired. And you can see here, we've got a button here to open and download the trace files. And actually, I find the easiest way to look at those trace files is using Sysdig, our open source tool. So I'm going to work on that same Linux host that I was working on before and run Sysdig. And Sysdig is, again, fully open source tool, and it's designed to process these system capture files and give us a powerful way to do deep troubleshooting of the environment. So here, you're looking at every single system call on that machine that happened when that alert fired. We can take a look at different views here, and we could take a look at container views. And so now it's going to reprocess this and filter information and aggregate it according to the containers that are running on this machine. And so what we could then do is now we see what's happening with Mongo. And if we wanted to, we could dig into this and go even deeper within in terms of understanding what Mongo is actually doing. So as you can see, using Sysdig, you can get very, very deep into an individual host, an individual container, a set of system calls that most troubleshooting and monitoring tools don't give you the ability to do it all. They simply stop at dashboard and call it good. All right, so you've seen a few things here. You've seen, we've shown you how to create a topology view of your environment. I think I'll hop back there, in fact, as a just a place for us to talk. You saw how we were able to use Kubernetes data in order to give you a true understanding of your topology, and not just containers, but what services you're offering. We're able to look inside those containers and troubleshoot applications. We were able to explore our system dynamically. We were able to create alerts and troubleshoot those alerts based on information we were looking for. So that's the entire demo that I was hoping to show you. Hopefully, this is a pretty powerful way for you to see what Sysdig can do with containerized environments that legacy infrastructure monitoring tools simply can't. One last item here before I stop for any final questions, which is what are our offerings? So we essentially have three offerings: Sysdig Cloud, which is what I demoed today, and gives you a hosted way to do infrastructure and application monitoring. It starts at $20 a month per host. Sysdig On-Premise, which is our same software as the cloud, wrapped up and delivered to you to run in your own cloud or in your own AWS domain. Could be a public cloud environment, private. It's all good. Only difference is primarily here is we only do this on an annual basis, and there's a minimum commitment. And finally, Sysdig Open Source, which is a CLI-based troubleshooting tool. It's only used on a single host at a time, has hundreds of thousands of users already, and has a pretty robust community for support. All right, well, hopefully this demo was useful for you. Certainly the best way to see this running in your own environment is to start a free trial today, and you can do that at sysdig.com. And from there, you can actually monitor your own services, see how intelligent we are about finding your own applications, dig deeply with trace-driven troubleshooting, and get deep container visibility all on your own. Thanks very much. I will stop now and see if you have any final questions for us during this demo. All right, as always, you are welcome to contact us at any point in time if you need help or you need more information in order to figure out if this is the right product for you. Thanks, everybody. Have a great day.